Welcome to qnawire.
Hi, so first of all, let's review a little bit the model that we're using. So in this case, we're employing the particle in a box model from 0 to L. And the wave functions, for example, in the case for n equal 1, it is going to look like this. We're going to have a single node. And in the case for n equal 2, right at the middle, we're going to have this node over here. So the wave function that we're going to get is the one at n equals 2. If we want to sketch this as required in the problem from 0 to L, let's say that this is the longitude over 2, like around here. So our sketch would look something like this. And now we are asked to, on this curve, shade the area which represents the probability of finding the electron between x equals 0.15 and 0.35 nanometers. It is important to label this that the distance L is 1 nanometer in this case, right? I'm going to redraw this such that the gap is precisely at the center. So the area in between 0.15 and 0.35 would be essentially 0.15 away from one side, 0.15 away from the other one, and the area would correspond to the following shaded area. And here you could add the labels 0.15 and 0.35. Next up, we need to calculate the energy in electron volts of the n equal to state. For this, remember that the energy for the particle in the box, it is going to be En. It's equal to h squared divided by 8 times mass longitude squared times n squared. In this case, we are doing the calculation for the second level, so this becomes 4 divided by 8, which is 1/2 of h squared divided by 2 ml squared. So this would be our result that we need to calculate. So the only thing that we need to do is to substitute the values. The value for h is equal to 6.626 times 10 to the minus 34 joule second squared divided by 2 times the mass of the electron, which is 9.1094 times 10 to the minus 31 kilograms, times the longitude squared. So we have nanometers, so this is 1 times 10 to the minus 9 squared meters. So the result that we can get from here is going to be in joules, and this is equal to 2.4098 times 10 to the minus 19 joules. And this quantity, we can convert it to electron volts with the following conversion factor. We know that we have the energy in joules. We know that 1 joule is equal to 6.242 times 10 to the 18 electron volts, giving us as final result 1.5 electron volts. And this would be our final answer.